Good morning, everyone. I'm Norbert. Thank you very much for waking up so early and being here. So I'm from Gevulot, and I'd like to introduce you to the decentralized prover layer we are building. So we felt that the proving market is susceptible to centralization, and that's why we felt the need for a decentralized prover layer which can legitimately compete with centralized options, both in speed and cost. And these are the lines that we started building from. So we want to make sure that no one can control where compute happens, where proving compute happens, and we want to ensure that proving workloads can flow to where compute is cheapest and fastest. And if we don't address these, then it greatly favors centralized proving. What we are building is a decentralized compute network which is exclusively optimized for proving, zero-knowledge proving and verification. We are going to offer cheap proofs because we are looking to aggregate proving workloads from all across the industry. And also, we have a very lightweight network designed and optimized exclusively for proving. We're going to be performant because from the same fact that we are optimized for the job of proving and verification. The network is very lightweight, and we are also flexible because you can permissionlessly deploy any arbitrary prover program on Gevulot. We support different languages. You need minimum modifications to deploy them on Gevulot. We support multi-threading, GPU proving, etc. So who are we actually? We are a permissionless and programmable blockchain for ZK, and you can deploy proof systems as on-chain programs on Gevulot. I'll talk a little bit about this on the next slide, but here I'd like to emphasize that we are prover-centric because we allow maximizing hardware utilization and financial return for provers through aggregating workloads all across the industry. And we offer low cost, high performance, high liveness and availability execution guarantees. We are permissionless and credibly neutral. A little bit about our network overview, like how does our network look? Programs on Gevulot come in two flavors, prover and verifier programs. The same way as you deploy a smart contract on Ethereum, you can deploy prover programs on Gevulot. The blocks on Gevulot include transactions and proofs rather than smart contract state transitions. So we don't host smart contract state, we don't do re-execution, very minimal necessary for the underlying blockchain. But other than that, we are super lightweight. So in a nutshell, basically any application requiring ZK proofs, they can send a proof request to the prover program deployed on Gevulot. Our network of providers will process that request, and the underlying blockchain will handle broadcasting the transactions, forming consensus, handling transfers, staking, proof system deployment, etc. We've got two main network actors, validators and provers. The main tasks of validators are processing transactions, broadcasting workloads to provers, forming consensus on block content and replicated state. The block building happens in a way that we select a leader randomly for every block, and the leader is responsible for ordering transactions and proofs into blocks. There's going to be a small fee per transaction, but that's minor and mainly to prevent spam. And a block reward is going to be paid to the leader. On the other hand, the provers have two main tasks, proof generation and also verification. So the selected prover or a small subset of provers is going to do the proof generation itself, but all provers, the entire prover set is going to perform verification. For participation, the provers need to be staked and will do capacity verification through proof of workload tasks. We'll have initial verification, and we'll also have periodic random verification just to make sure that our prover set, our active prover set, is constantly capable and available for proving tasks. The workload distribution among provers happens through a verifiable random function, and we will allow customizable redundancy in case user preferences or priorities necessitate that. And there are two important things I'd still like to mention: decline and fallback mechanism. So our provers have the opportunity to decline certain workloads. There will be a quite strong limit so that they don't exploit the feature, but we don't want to penalize provers who have some ad hoc constraint at their end. On the other hand, if a prover declines a job or simply fails to deliver the proof, then we have a fallback mechanism which is quite simple. We open up the proving job for the entire prover network who can jump in. It's a proof race, and anyone can deliver a proof. The fastest one will be rewarded. So that's important for us to ensure that no proof request remains unproven when sent to Gevulot. The life cycle of a proving workload, just in a nutshell, so that how does it look in practice? So users send a run transaction to the network. The receiving node adds the transaction to the mempool for inclusion in the block, in the next block. Once the transaction's been included in the block and finalized, it's randomly allocated to a prover node. If the user wants to have additional redundancy, they can submit another transaction with the same input to the same prover program, and then it's two provers kind of racing. The prover node completes the work and submits the proof back to the mempool for verification. At this point already, so it's important to emphasize, I think, at this point already, the proof can be shared with the user. So if you're looking to do settlement and verification on Ethereum, you are free to do it already at this point. However, we do need verification internally as well to make sure that our provers are actually, or like they've done their job properly. And this is also needed for us to process the prover rewards. So we do verification, all provers participate in doing the verification. They vote on validity, and as soon as we reach 2/3, the proof gets included in the block. It reaches finality, and the reward is distributed to the prover. However, as I mentioned, this is independent of the user being able to use the proof as soon as it's been generated. Doesn't need to wait for our internal verification if settlement is done elsewhere. So in a nutshell, taking the example of a validity rollup, users submit transactions, the sequencers build blocks, batch transactions together, they send the inputs to the right prover program, proof system deployed on Gevulot. Our network will process the proof, generate the proof, send it back to the sequencer. The sequencer can already continue working with the proof, and internally we will have it verified. It will get added to a new block, and then it reaches finality and provers are paid. A little bit about prover economics. The proving workload fees will contain two components: a small transaction fee, as I mentioned, mainly serving for the purpose of preventing spam. And there will be another item called compute fee. When users submit a proving workload, they need to specify resource requirements and maximum compute time. And based on these two inputs, we will, or these two parameters, we will calculate the fee. You can see the fee calculation at the bottom. On the other hand, there is one important thing to mention. So this initially calculated fee will be logged from the user's balance until the workload is completed. However, that's most probably not the final fee deducted, because we have a so-called user fee rebate mechanism, which means the longer it takes for the user to receive the proof, the less they are going to pay. It means that basically we incentivize provers to do proving as fast as possible, or else proportionally to the elapsed time in proof generation, we will decrease the reward paid to the provers, and the difference between the initially calculated fee and that final reward to the provers will be rebated to the user. We've got custom prover sets. The main role of the custom prover sets is to manage external dependencies, so you can plug in external software for different diverse use cases. You can plug in specialized hardware. You can run proprietary prover programs on Gevulot. You can plug in data management, data storage, and data availability solutions. This increases network efficiency, introduces like a demand-based network evolution dynamic, and participation is voluntary for provers, but any prover can opt into multiple custom prover sets as well. We'll have verification tasks for them too upon when they opt in, to make sure that we know they are available to do proofs and capable of doing proofs within that custom prover set. We've got some technical aspects here, but it seems I'm running out of time, so we could talk about this offline after the talk. Just a couple of quick things. We've got like the deployer of the custom prover program will determine the price of the proving, but will initiate or introduce a minimum prover cost to prevent undercutting. By default, there's going to be no subsidy for these custom sets. However, proportional to the percentage of the global prover set participating in a custom prover set, will process the same proportion of network subsidy for that. So 50% of the entire prover set participating, that would mean 50% network subsidy. And as I mentioned, use cases could be exotic hardware integration, data storage, data availability solution integration, any external software dependencies, or like STAC. To do proving for STAC, you need the full state of STAC. So if our provers don't want to run the full STAC node, then they could connect to some source. And we allow, through custom prover sets, interoperability with different blockchain platforms as well. Our DevNet is live. Some stats: 200K plus proofs generated, 700K plus verifications processed. We've got the Starkware Stone Prover pre-deployed, the Tycho Prover pre-deployed, and some new ones are coming. Our testnet is planned to go live in Q3, and with mainnet launch, we are planning to proceed late 2024, early 2025, but in a perfect world, it's late this year. To join the DevNet, please visit our website or check out the QR code. And yeah, we would be very happy to have you test our DevNet. Thanks.